one last time, I guess. I think we will start by a show of hands, which is, of the people in this room, how many are convinced that DeFi is the future of finance, let's say? Awesome. Pretty much everyone. We're not going to be that adversarial here. Let's say we're going to introduce a complementary vision to that. My name is Ola. I'm the founder and CEO of Delta. This talk is going to be a little bit of a, you can call it a taste of what we're up to. We're not really going to go public for another few months. This will be fairly high level. You will hear more about us in the future, but the goal of this talk is really just to give you like little tidbits here and there about what's going on. The talk is structured as follows. We'll go into the architecture, again, staying at a fairly high level, getting into the properties that are enabled by this, the kind of overall, overarching vision, and then we will touch on two financial applications. All right, so, getting into the architecture, everyone here is probably like a, lowercase r researcher, blockchain nerd. It looks a lot like a modular blockchain where, okay, we have this like stacking of the two-dimensional layers, visualization. The base layer is populated or run by this distributed validator set. They, are passing data around. They're also verifying snarks. Where do the snarks come from? They come from, again, with this visualization, the layer above, which is execution layer. This consists of all of these little colored dots. The different colors are there to symbolize how heterogeneous this is, how distinct they can be. So basically what happens is the user submits a transaction to one of these little dots, we call them domains. There, the transactions are ordered into these ordered lists that some would call blocks. They're executed. The result of this execution is sent down to the base layer, as is a proof of valid execution. A bit later on, because SP1 and the like, there's a bit of latency there still. So where this really differs from, if you look at this, it kind of looks like we're ripping off like Celestia or Ethereum or something. The main distinction is there's a single global state. So the little dots, what we call domains, they're not actually rollups. They're not independent blockchains. They're more like, states in a federation or something like that, where they enjoy like a large degree of sovereignty, but they're still tied to this, single global state machine. As mentioned, we have a standardized messaging format where, these stated lists are used to just compute the changes or apply the changes to state. So they're like the output of the local execution, and then on the settlement layer, they get applied, upon settlement via snarks. Settlement via snark verification. There is also, recursion here. Uma was touching on Fry-based recursion, which we will also have here. And what that makes is for this nice little, a single state proof. This is sort of like what Mina has, where you can run a full node and independently verify the entirety of state by just doing a bit of like Merkle proofs and a bit of, verifying the root against a single snark. Quite nice. So what are the properties that are enabled by this? One important one is that there is no bridging within this system. So as mentioned, we have these roll-up-like things that we call domains, which are these execution environments. You can move between them very frictionlessly. There's this word seamless, which I feel it's just been like used and abused in this space. So I feel a bit bad about, again, bringing it up. But really, you are just like moving within a single state machine, so it's very nice and secure. This also means that you have censorship resistance. So one of the main concepts that we introduce, and which I will touch upon later, is the distinction between local and global properties. Locally, you can have a centralized domain run by, you would call it a centralized sequencer, we call them domain operators. They can run them, you know, as tyrannically as they want to. And the thing is, locally, you would not be censorship resistant, right? Like, you're submitting your transaction to this single guy, he doesn't like you, you're in trouble. But because we're within this big old global state machine, spinning up new domains, by the way, is permissionless. So the censorship model is really, a censorship resistance model is really that you can just like, you can move between the domains. You don't have to go through your own like home domain or the current domain. You can talk to the destination. They can themselves verify this transaction because again, they read from this global state. Bridgeless, it's not like the roll-up like escape hatch thing where you go via the L1, cumbersome. So quite nice. And then we introduce sort of new trust assumptions where the idea is you want it to be possible to have sort of to have minimal trust assumptions, like only relying on like public key and hash-based cryptography or something like that, which is the case here as well. And then on top of that, we allow for domains to these execution environments to live with, you know, a variety of different trust models. They can choose to prove the entirety of their computation, but they can also choose to just adhere to very few global laws. So I will get back to this, you know, this idea of the federation. You have basically certain laws, certain rules, things like signature verification, which, you know, need to be valid everywhere. Every domain, no domain can spend from anyone's account without receiving a valid signature. And you can steal all your money, it would be kind of, you know, bad. But then beyond that, they can choose sort of to what extent do they want to provide their users with the maximally trustless, like we're just going to prove everything approach, or, you know, we are Coinbase or Fidelity or something, you know, you're already trusting us with like doing the stuff that you want us to do without providing a cryptographic proof. So we're just going to continue doing that. And then the thing that we get from all of this is we get super heterogeneous domains because, again, we're allowing them to compete across many, many different axes. We keep this very minimal set of global rules and standards that everyone has to adhere to. That's things like, you know, at least originally we're just going to start with a single proof scheme. So like, you need to adhere to that. You need to adhere to the messaging format that is the stateless. But execution, which takes place locally because of cryptographic proofs, you know, you can kind of do how you want it to. All right, what's the grand vision? We're gonna present this from like the inside perspective and the, call it internal and externally. So internally, what this looks like is what I would call the minimal viable federation, where you have this federated state, maybe like the US, I live in Switzerland, like Switzerland, where, you know, you have something like membership states or cantons which have a large degree of sovereignty. They can, you know, largely define and determine what their own execution environments are going to look like and how they're going to behave. But this exists within, you know, a greater state which does have some general laws and rules. The idea is to make the latter minimal to the point where, you know, we want to ensure interoperability, we want to ensure certain security properties, and then beyond that we get super opinionated, distinct, heterogeneous domains. So what this leads to from the outside looking in is what we call the opt-in empires, where each domain can have an emperor, can be run centrally, without harming any of the security properties of the individual user. So again, what the minimal viable federation enables is this set of super opinionated membership states, if you will, which can rule as they like within the bounds which are defined by just quite a minimal set of global rules. That brings us to the two example applications that I was going to mention. Generally, I can imagine that what I presented so far, it does imply this sort of, okay, you can run these centralized financial applications or service providers on a domain. You can do it centrally. You run your own execution node. And at the same time, all the users have their self-custodying. They have ownership of their assets, and they're kind of part of this network of such applications and can move around freely. So the first example is a censorship-resistant centralized exchange. This is run essentially exactly like a, call it current Coinbase or Kraken or whatever. Any given off-chain centralized exchange could be run like this. They just need to provide, a little bit of extra data. They need to, assuming that the users are custodying the assets themselves. The exchange needs to provide, a proof of things like signature verification and nonce verification and things like that. But running a Delta domain. But basically, the UX, the onboarding, everything should feel like onboarding to a centralized exchange. Then additionally, you're on it. It's this like centralized entry point. You're automatically part of this whole thing. With all the other applications like this, you can move around. You cannot get fucked over. You cannot get SPF'd. And yeah, you're kind of like, you have the freedom to choose to stay here, but this is really like a market-driven decision, right? And then from the exchange's point of view, this is also nice because, again, there are these general standards and rules that that apply to all the different domains, and therefore the interoperability, properties are very good, and the exchange can. We don't really care about atomic interoperability, but we will enable it across domains, so they can do that if they want to. We suspect that there will be much more like async, non-atomic composability, but also, the market will decide. The other and the last application that we will go through is a payments network. So here we think of Delta as kind of a network of networks of sort. One of these domains would run a payments network. It can now very easily comply with regulations, which are typically a pain in the ass for payments. AML and they can say no, we're only going to do KYC users or whatever. So that's suddenly trivialized. The nice thing here as well is that even though you are transferring money through a single centralized entry point, single domain, because of the global state, there's no bridging. Again, there's no bridging within Delta, so you can you can send your money to anyone, anywhere, just as frictionlessly, as easily as you could within your own domain. And then again, you have the same benefits of both on the side of the user and on the side of the network, the application itself. You have access to all these other applications that you can integrate with at will. As a user, you can jump around, and everything is nice. Yeah, that's pretty much it. I didn't want to give a super deep dive. I hope everyone has gotten a little taste of what it is that we're doing. You can find us here. That Twitter does not have anything happening yet. We'll go maybe like a month or two. Thank you.
Thank you. Any questions from the audience? users need to have a direct, and I'm assuming in your case, like every domain could be a separate sex, right? Is that a good way of
Yes.
doing it? So would I have to first sign up with the sex directly and then integrate that into Delta? Like, well, you know, it seems like don't sexes really have to retool to support this because it sounds like.
Yeah, probably a little bit.
Okay.
Probably a little bit. I mean, for this example, you would need a sort of on-chain account, right? So
Yeah.
that in and of itself, there is a little bit. But the point is, for example, the matching engine does not have to be proven. There's a lot of computation that doesn't have to be proven. So, you know, I'm not going to say that it's like a zero lift, but should be pretty feasible.
What is the incentive for a sex to join the Delta network?
Yeah, sorry. We can think of this from like a single player or multiplayer. You know, single player, only the sex is there. Maybe it's not super useful. Assuming a world in which there are a bunch of different domains and a bunch of different users around, I mean, you have this, like, you're automatically part of a much bigger ecosystem. So there's kind of this, you know, there's like the carrot or the stick. Like, you don't opt in, someone else does, and they get the users, because the users can suddenly now, like, use their same account for, like, their, you know, Uber or whatever, right? Because it's part of the whole thing. So that would be the main reason.
Yeah, because I almost feel like, you know, if I'm a sex operator, I'm a big sex operator, I kind of want that liquidity locked up within my whole garden, right?
Yeah.
Under your model, it kind of resolves to this like self-custodial-ish type of layer. So is the pitch there for like tier 2 and tier 3 sexes to
Probably.
Okay.
Probably initially. I mean, this is interesting. Everyone should look into, you know, the rise of credit cards in the US, where I'll be brief. It started out with like every department store and every little business had their own, like, and it was basically like a loyalty card. And then some of the big, like, general ones came out, but the big department stores and big ones that had their own, they didn't want to opt in for a long time because of the reason that you're, you know, bringing up. I suspect we will see similar things.